Assignment 2 of DBMS. First off, we'll talk about the DBMS applications where all the database management systems are used. First, we are using it for bankings, for customer information, accounts and loans, and the banking transactions. The next is airlines for reservation and schedule information. Airlines were among the first to use databases in a geographically distributed manner. Terminals situated around the world access the central database system through phone lines and data networks. Universities for student information and course registration and grades. The next one is telecommunication. DBMS application is used in telecommunication to hold the records of calls made by people, also for generating monthly bills, maintaining balances on prepaid calling cards, and storing other data. The next is finance. DBMS plays a crucial role for the finance department by storing information about the holdings, sales, stocks, and the purchases of financial instruments such as bonds. The next one is sales for our customer product and purchase. Sales also comes under the finance in the application of DBMS. Next one is manufacturing. Manufacturing, we store how the products are, what all products are, which all products are manufactured. We'll store their data and the products data and their prices along with it. And we can also track the number of productions they made in factories, inventories of items in warehouses, stores, etc. The next is human resources. For example, when a person is working in an office, his salary, where does he live, his payroll, taxes, and benefits, and for the generation of paychecks. This concludes the use of DBMS application. The next one is data abstraction. Data abstraction actually means hiding data or showing only data that is required to the users. There are three types of data abstractions. The first one is the physical level. Uh, yeah, the physical level data is the data which is at the lowest level, and it describes how the data are actually stored. And the physical level describes the complex low-level data structures in detail. The next is the logical level, which is the next higher level of the data abstraction. It describes what type of data are stored in the database and what relationship exists among those database. Data administrators are actually who must decide what information to keep in the database and use the logical level of abstraction. Now we'll move on to the last level, that is the view level, which is the topmost level, and it's the highest level of data abstraction. Only part, and it describes only part of only the very much part of the data in the entire database. The view level of abstraction exists simply to simplify the users with the system. The system may provide many views for the same database. Now, yeah. Next is the database terminologies. What all terms are there in database? The first is data independencies. It is defined as that property of DBMS that helps us to change the database schema at one level without causing an effect or a change in the next higher level of the system. And data independencies help us to keep data separated from all programs that make use of it. The next term is instance or snapshot. Instance or snapshot, as we know that when we have data, it changes over a period of time as the user inputs values, user adds and deletes the values. Data base varies. So data that is stored at a particular instance or a particular time is called the instance or snapshot of the database. Schema is the overall design and the overall design of the database on how the database is stored. Now, moving on to the next one, it is the DBMS architecture. In what ways are the database architecture arranged? And it is in the form of tier system: first tier architecture, second tier architecture, third tier architecture. When we come to the first tier architecture, it is a architecture in which the database is directly accessed by the user. There is no interface, there is no view, nothing for the user to access. He directly accesses the database, and it is directly available to the user. For example, the user can sit on the database management system and use it. The client, the server, and the database all present on the same machine. One example of this is SQL, in which we set up our server in the laptop as well as our database on the local system. And it is sometimes also referred to as centralized system with single user system. Centralized system with single user system. The next is the two-tier architecture. In the two-tier architecture, there is actually a view or a client present. The client will be further entering the data and the processing will take place in the database. We have seen this example is basically used in two-tier architecture, can also be called as two-layer architecture. So there's a client and then there is a database. We have seen this in when there is when we are in a shop and when the customer, I mean the people who are sitting on the counter enters our data, and the data they're entering, basically they are the client and they're basically entering the client's information, and the information data is being further stored into the database. It is also called as a client server model. So the application at the client end directly communicates with the database at the server end. APIs like ODBC, JDBC are used for the interaction. And the thing is, on the client side, the user interfaces and application provides programs are run. The application on the client side establishes a connection with the server side in order to communicate with the database. Now moving on to the third tier architecture, in which there is 3 layers present. The first layer is basically the client. The second layer is an application or a platform where the processing takes place, and the third layer is the database where the data is actually stored. So the client does not directly communicate with the server. Instead, it interacts with an application server, which further communicates with the database system, and then query processing and transaction management takes place. The intermediate layer acts as a medium for the exchange of partially processed data between the server and the client. Now moving on, we have the problems with this was in the first tier architecture. Data, we are directly entering into the database, so it is very hard to actually enter data for the people who didn't know how to do database. So a second tier architecture was used. The second tier architecture has an advantage of being very fast because of it is given to only a few number of people. The problems arise when the second tier architecture, when large number of people are using. So nowadays, most of the time we use third tier architecture because many people can access it, many people can use it at the same time. The next is the server system architecture. That's what we'll be studying about in our database. The server system architecture is divided into transaction servers and data servers. Transaction server systems are also called query server systems, and it provides an interface to which the clients can send requests to perform an action. It responds to in which they execute the action and send back results to the client. The next is the data server system. Data server system allows clients to interact with the servers by making requests to read or update data in units such as files or pages. Then the thing is classification of data management systems. It is also classified on various kinds. The first kind is the classification on the base of data model. It is divided into relational data model and object-oriented data model. And the classification on the base of user numbers, it is divided into single user system and multiple user systems. And classification based on database distribution, it is centralized, distributed, and distributed is further divided into homogeneous and heterogeneous. Thank you.